just soldering the last few components now, and then I will go and check the board to see if it all works. Debugging Sprites 2 board. On its own, it is plugged into pixel header 1, the second pixel header, 0, 1, 2, 3. You can see here. Now, I think it's a 5 megahertz oscillator is enabled instead of the video clock. If I enable the video clock, okay, I was getting scanline stuff, but it's not there anymore. The scanline RAMs seem to be cleared. Let's reset the video. Okay. Okay, the video has been reset. Now, if I run this code, all it does is that it sends 8 bytes of 0, 1, 2, 3, 4, 5, 6, 7, 8 of 0 to the sprite displays, the definitions, right? And it enables pixel header 1, which is the second pixel header. Now then, when I run this code, and then it waits for fire to be pressed, and then after that it displays 1 frame of the intro, the wavy flag effect, and then it waits for fire again, and then basically it does this. Right, press fire, does that, does this wavy, and then it does the thing, the rolling intro with the scale, brings on sprites and stuff, and then pressing fire again shows this. However, what's interesting, I've noticed, is that if I enable the video clock, after running that code and not even pressing fire, but just enabling the first 0 bytes for the sprite definitions, using vid clock, I get this pattern. This pattern seems to indicate somehow that the sprite RAMs aren't being cleared. If I disable video clock and I disable the clock oscillator, now disabling the video clock means that there isn't any calculation going on at all going into the sprite scanline RAMs, which means that this data that I'm seeing should be data that's cleared from the scanline RAMs, but it doesn't seem to be getting cleared, which is odd. Maybe what I should do is that I should enable the background layer. So I'm going to enable the background layer differently. I'm going to enable the first layer of sprites, and then the last layer is going to be pixel header 4. So I'm only mixing the first layer from the sprites 2, and then after that, oh, why is that doing that? Oh yes, because it's not 4, it's pixel header 3. Okay. Now the reason why I removed the other layers is that I was thinking maybe there's power drain or something like that. This is the last layer. It's floating on the hardware, so there's not going to be any display. Okay, but pink, 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 pink. That's what I should see. On this, it's displaying the character screen. That's that. And of course, this code doesn't upload any graphics data, which is also important to note. Okay, so if I run this on Commodore 64, or at least the layer that's behind should be a floating high pixel color, which should be color 255. Huh. This is interesting. It means that the data that I'm seeing here is coming from the sprite RAMs. If I enable, without any calculation logic enabled, if I enable the video clock, I get this. If I disable it, I get this. Seems to indicate that the sprite RAMs are being cleared, apart from this vertical line. The vertical line might be because, don't know, could be an address problem. Okay, if I enable the 5 megahertz oscillator, I think it's 5 megahertz, maybe 4. Anyway, way slower than the video clock, then I'm getting this with 0 sprite data. What this means is that, oh look, now that information has been cleared. If I enable this again, then I disable it. Okay. What this might indicate is that the information that was being programmed into the sprite positions, definitions, etc. is not being set into the memory properly. Maybe it's reading rubbish. But then again, okay, this is the interesting thing, is that if I set to be using the video clock, or if I set to be using the oscillator. Now the oscillator I'm not going to use, I'm going to use the video clock. Like this. Okay, no, I'm not going to use it, I'm going to use the oscillator. The oscillator is slower than the video clock. Okay, so if I do this, and if I press fire now, it seems to set something. Look, this is what I'm seeing here. I'm seeing this kind of swoop, right? Now, if I run the code and press fire, swoop, there is some kind of line here, look. Zook. So it indicates that it might be trying to draw something, but it's not right here. Might mean that, who knows? If I turn off the clock oscillator, and if I turn on, that's interesting. This might be interesting data. The thing is that without any clocking, it might be trying to continuously draw the same vertical section of the sprite because it's not able to latch in or read in and into the latches and new information, so the calculation logic might be doing this all the time. Might be something to do with that. Yeah, anyway, if I enable the video clock, right, the video clock, interesting. The video clock also seems to be, look, there's this swooping up, and there is this thing here, and it goes ding, 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 which is what kind of I see on here. So there is something being read for the position, but it is not consistent, and it is flashing and flickering. Maybe I try and draw one sprite. Yeah, I'm going to try and draw one sprite without any scale or anything, and smack bang in the middle of the screen without doing the whole thing. Because if the slow clock crystal, interesting, if the slow clock oscillator doesn't have time to draw the whole scan line, maybe it's not resetting the logic properly, and that's why we're getting this. Is that it's just not able to draw something properly, and it's overflowing this, maybe. This, however, is meant to be fast enough-ish. Okay, anyway, I'm going to draw one sprite. Not this problem again. Look, watch. When I touch these resistors, watch what happens to the display. The flickering stops. One of the scan lines is really not correct still, but the flickering stops. Oh, flip. Really? Seriously, this problem again. If I don't touch one of them, and that's with my thumb. Huh. Oh, look. Touch, and then it seems to stabilize. Great. Now if I touch above, yeah, if I touch the resistors above, this happens. Great. Not, oh, okay. Something weird has, okay, this means that it might be trying to clear on the other one too, but it doesn't seem to be having such an effect on the other scan line. So there's a different problem. But if I do it here, it seems to be clearing, not clearing. Right, there's that ghosting off effect. The resistance values is not correct again for this particular layer of the board. Oh, I really do hate this. Okay, so I'm gonna different resistor values. Here, I don't know why, because it's the same parts. We'll see. Anyway, maybe I'm using the old resistor values. I shouldn't be. I need to check to make sure that the resistor values here are the same ones as they are on the sprites, because this arrangement works on the sprites board. Anyway, up here. Oh, great. Okay, fine. So I'm going to continue debugging a little bit with setting some solid sprite data to see what I can get. Accidentally enabled the vid clock and the clock crystal at the same time, which produced a short circuit. Whoops. Which reset the video card, and then blank screen, blah blah blah, because it lost power. However, look, didn't quite lose power, because now that I've got 5 megahertz oscillator enabled with the single sprite debug information, there is something. The scanline RAMs got cleared. And if I touch these resistors, no, nothing good happening there, but there is something like an M, which is the graphics that I see. I mean, I wasn't seeing this M. Yeah, I wasn't seeing this M. When I was using vidclock, I was just seeing rubbish. Disable oscillator, enable vidclock. Something there, but not anything really recognizable. It's just in the right place. If I press fire, it moves, doesn't clear. Again, this weird kind of like not working clearing mechanism. Okay, I'm gonna get a resistor and try that with this. Where is the camera? with this resistor here. Note R24 produces this. The second one on the other scanline RAM doesn't do much, but R24, if I jumper it across, lowering the resistance, of course, resistors in parallel. This. The other resistors don't seem to do it at all. Just this one, okay. This is the second scanline RAM. Just probing and exploring like this, dragging it across. Okay. Maybe second scanline RAM seems to be really bad, but this one, not too bad. If I lower the resistance, great, of just R24, maybe R24 has a bad solder connection. I'll check it out in a minute. So some debugging progress now. I've managed to jam that resistor into R24. You can see that, and I've got the first two sprite datas correct. Now sprite definitions uploaded. Now the 1024 bytes, 32 by 32 bytes uploaded. One of the sprite scanlines is correct. The sprite seems to be in the correct position. If I press fire, it moves over as expected in emulation. Sprite palette data seems to be correct. Press fire again. Okay, the other two sprites, the first two sprites are uploaded, but the other ones are not uploaded because I'm using the Commodore 64's RAM, and RAM is limited. I might include all of the other data. Might do that. Next one, you can see the swoop is okay. The swoop is okay. Press fire again. It zooms around as you would expect, and this screen comes up. It looks not too bad. And you can see, because I'm using vidclock, the fill rate is not quite good enough, because I optimized this demo for a higher fill rate, 14.31818 megahertz, or whatever it was. I think it was. It's in the feature file anyway. So now if I press fire again, something is there. Looks like it's not too bad. The other sprite scanline RAM is completely bored, though I don't know what's wrong with that. I'm going to need to debug that properly. Touching it doesn't seem to produce any effect. Okay, it's just alright. Not too bad, not completely broken, just one scanline seems to be broken. I'm going to try the oscillator now. Oops, let's turn off the vidclock first. Turn on the oscillator. It doesn't like running at a low frequency or something, I don't know. It's producing something recognizable, but really it's not happy at the low frequency. Let's rerun that again. See. Okay. Maybe the clock crystal's not good. Let's just put it back to vidclock for now. I'm going to try it with a different clock crystal speed. Debugging process update. I've swapped over the oscillator now, so that it was using previously, it was using a 4 megahertz one. I remember now, there needs to be enough clock rate for the oscillator, for one of the internal latches, to pick up the two video pixel clock reset signal, which strobes low at the beginning of the scan line over here. If it doesn't pick it up, then all of the internal logic doesn't clock properly. So that explains why the 4 megahertz oscillator was really producing not the correct data. So now what I've done is that I've enabled a 14.31818 oscillator, because I bought one of those to match what I could measure from the simulation. So I think it was for 14.318, yeah, 14.31818 megahertz, right? And that's what I measured in the simulation as being kind of like stable. And look, so if I press fire now, again, same kind of thing as before. Now then, I should have fill rate now. So when I go to this part of the demo, it spins around, goes to this demo, and now the fill rate should be fine, and I don't get the missing sprite data. It doesn't go boing into basically the draw fill rate is high enough now that the observed hardware performance matches what I was observing in the simulation, and of course the emulation emulates this. I still have to debug why this flipping scanline RAM here is not working, but apart from that, it seems to be actually not too bad. Positive. Small debugging update. This is using a 16, don't know if you can see that, this is using now a 16 megahertz oscillator, which gives it even more fill rate on the scan line. Wow. And it's actually quite stable. So this is now I'm going to rerun the code. This is now beating the results observed from the simulation. The simulation was getting unstable at around about 16 megahertz, if I remember correctly. This is basically overclocking the scanline drawing. It means that the components here are performing better than the components in the simulation, which is intriguing. However, I wouldn't really want to overclock it that much. You can see that it works. It seems to work quite well, but I'm really going to have to debug that other scanner. Wow, okay, not too bad then. I'm going to put it back to the 14.31818 megahertz clock oscillator for now, I think. Debugging update. Now I'm uploading all of the sprite definition data for the first bank anyway, not all of the extended sprite definitions. And you can see here that everything looks good for the working scanline. Compared to this, not too bad at all. Spins around quite nicely. Moves around quite nicely. Pretty cool. Like I say, I've not uploaded the other bank of sprite definition data because it's quite large. That's running at a decent frame rate actually. I don't know what frame rate that's running at, but 1 kangaroo, 2 kangaroo, 3 kangaroo, 4 kangaroo, 5 kangaroo, 6 kangaroo, and that's 320 pixels, I think. I forget. So that's 60 frames a second. Okay, that's marvelous. I really need to fix that other scan line now. I don't know what's wrong with it. Could be anything. Could be one of the latches. Could be the RAM itself. I don't think it's the RAM itself. Don't know, we'll see.